Let's look at this homogeneous of degree -1 for lambda star one more time. There are multiple ways to explain this or to prove this. The one that we did in class probably wasn't the easiest one to actually look at it, but we have a different way. And in class, we will talk about other ways as well. So remember that we are trying to find interior solutions under constraint, and we know that an interior solution has to satisfy the first order conditions for the Lagrangian. So we set up the Lagrangian and then we get the first order conditions. That's the starting point. So we will have u1 minus lambda p1 is equal to 0, and u sub 2 minus lambda p2 is equal to 0. And then the last one is m minus p1 x1 minus p2 x2 is equal to 0. And we assume there is a unique solution, a unique solution over here. And that's going to be our x1 star, x2 star, and lambda star. And all of them are functions of parameters m and p1 and p2. So we're going to call this system over here system 1. Okay. So that's what we have. And remember, x1, u1 is the partial derivative of u with respect to x1. And so u1 is really a function of x1 and x2. And u2 is a function of u2 and x1, x2 as well. Okay. So just remember this. And so what we have over here is that x1 star is a function of m, p1, p2. And x2 is a function of m, p1, p2. And also lambda star, a function of m and p1 and p2. And this triple is a unique solution to this system 1 over here. Okay. So now we wish to show lambda star is homogeneous of degree -1, and x1, x2 are homogeneous of degree 0. Because of the special form of first two equations, we say we can eliminate lambda. So really, x1 star, m, p1, p2, and x2 star, m, p1, p2, they are unique solutions. Really just one to this list of equations of 2. One is u1 over u2 is really equal to p1 over p2. We divide the first two equations, and that's what we have. And the second one, we have m minus x p1 m x1 and p2 x2 is equal to 0. So now let's look at this system over here. Normal lambda and rescale. Let's rescale the equations over here. That means m goes to tm and p1 goes to tm, t goes to tp1, and p2 go to tp2. So we have this new system, u1. There is no parameters in u1 over u2, so it's still u1, u2, and that's going to be tp1 over tp2. And we see this is the same. Okay. And then we have over here tm minus tp1, x1 minus tp2, x2 is equal to 0. So after rescale, we know the solution should be x1 star tm TP1, and TP2, and x2 star, TM, TP1, and TP2. So this is exactly the same reason why we had these two, now they are dependent functions, but supply function is homogeneous of degree 0. So these two are solutions. To this system, to system 2 over here. Let me call this system over here, system 2. But 1 and 2 are the same system. But 1 and 2 are the same. So by eliminating lambda, we are able to show that x1 star MP1 P2 is equal to x1 star TM TP1 and TP2. And the same is true for x2 star. So we just say I is equal to 1 and 2. So that means these are homogeneous of degree 0. So we have xi star M P1 P2 I is equal to 1 and 2. They are homogeneous of degree 0. We use the same argument that we used before. Now we can actually show lambda is homogeneous of degree -1. So now we solve lambda. Because u1 is equal to lambda p1, so lambda is equal to really u1 x1 star x2 star over p1. To be complete, this is what we have. We have lambda star is equal to u1, which is a function of x1 star and m p1 and p2, and x2 star, which is a function m and p1 and p2, and divided by p1. So it is true, lambda is a function of m, p1, and p2. So now let's rescale. So let's look at what's going to be lambda star Tm and Tp1, Tp2. We plug in, that would be u1 x1 star and Tm, Tp1, Tp2. And we see that's what we have over here. x2 star is also Tm and Tp1, Tp2. We just scale all the parameters and including the one in the denominator. So we have Tp1. And remember, x1, x2, they are homogeneous of degree 0. So this is really equal to 1 over t. And we have u1, x1 star, m and p1, p2, and x2 star, m and p1 and p2, and divided by p1. And that's exactly the lambda star, if you remember how we defined it over here. Okay, and that's m, p1, and p2. So from this equation, we can also know that lambda star as a function of m and p1, p2 is homogeneous of degree -1. All right, that's it.